Hello everyone. I'd like to take a look at a couple examples where we'll be using one of our theorems that deal with the tangents to circles. This theorem states that if a line is tangent to a circle, it has to be perpendicular to one of the radii of that circle. So to put that to use, in this first example here, the question is segment ST tangent to circle P? So ST, and then we can see here T is on our circle. So we want to know if point T is a tangent point. So what we need to test is we need to know whether or not this is perpendicular. So PT, that's a radius of the circle. If ST is going to be tangent, this would have to form a right angle. And an easy way to test if this is a right angle is by using the converse of the Pythagorean theorem. So we know the Pythagorean theorem, a squared plus b squared is c squared. Where these are the two legs, and c is the hypotenuse. But we don't know if this is actually equal yet, and that's what we're testing. If it is equal, then the Pythagorean theorem is true, then it is a right angle. So the two legs of this triangle, so we have 12, and then the other one is 35, and then the longest leg is going to be 37. And again, we don't know if this is true yet, but hopefully this works out. So 12 squared is 144. 35 squared is 1225. And 37 squared, 1369. Okay. On the left-hand side, if we add these two together, 1225 plus 144, so that would be adding 104. So it does look like this does work. So this is true. So the Pythagorean theorem holds, which means that this triangle has to be a right triangle, which means that this is a right angle. So yes, segment ST is tangent. So that theorem, that this is perpendicular, that is a biconditional. It has to work both ways. So if we know that this is tangent, that has to be a right angle. If we know this is a right angle, this has to be tangent. So we can use the other direction then in my second example here. So this one is telling us that point B is a point of tangency. So now we're going the other direction. So I already know that this is tangent, so I already know that that is a right angle. And in this case, I want to find the radius of this circle. So one of the nice things about circles, the radius is the same everywhere. So from C to B, we can label that as R. And then from C to where it intersects the circle here, this is also R. Okay, I'm given some other measurements here. I know segment AB is 80 feet. And then I know from A to this point where it intersects the circle, I know that that's 50. Which means that the entire length from A to the center of my circle, that entire length is these two pieces added together, which is R plus 50. Okay, so now that I have all of that and kind of made sense of everything here, I have my three sides of a right triangle, which means, again, I can use the Pythagorean theorem. So a squared plus b squared is c squared. And in this case, we're not testing it. We already know that the Pythagorean theorem has to be true because we have the right angle. So the two legs, we have r squared and then AD squared. And now the hypotenuse, as we talked about here, the hypotenuse has an entire length of r plus 50. That binomial, we want to make sure we put that in parentheses. So r plus 50 squared. Now we just have to do a little bit of algebra to solve for r. We got r squared, 80 squared, 6,400. And then on the right-hand side, we are going to have to multiply this all out. So that does end up being a binomial squared, which, just to make a little note here, this represents r plus 50 times r plus 50. So we have to do the distributive property twice. So we have an r times an r. We have a 50 times r, and then a second one of those, so another 50r, and then 50 times 50 is 2,500. So let's see, we have some like terms that we can combine. 50 and 50 is 100r. And now we have to finish solving for r. We do have some r squareds, but I see that we have 1r squared on both sides. So if we subtract that, that will cancel out. So then we are just left with r to the first here. And then let's subtract the 2,500 from both sides. So that leaves us with 3,900 is equal to 100r. And then to finish, divide both sides by 100. The two zeros cancel out, and we end up with a radius of 39. We can take a look at that just to make sure everything makes sense. If my radius is 39, so it looks like the shortest side of this triangle is 39, so that looks good. And then if I do 39 for the radius plus the 50, we know that that has to be the largest side of the triangle since it's the hypotenuse. So 39 plus 50 is 89, which is bigger than the 80, so that checks out as well. So there are two examples using the fact that tangents to a circle have to be perpendicular.